What is check valve? A check valve, also known as a non-return valve or one-way valve, is a mechanical device that allows fluid, liquid, or gas to flow through a pipeline in only one direction. Its primary purpose is to prevent backflow, which occurs when the fluid tries to reverse direction. This reversal can damage expensive equipment like pumps, cause contamination, or lead to system failures. How it works. The cracking pressure. Check valves are self-actuating, meaning they don't require a handle, motor, or human to operate. They work based on a pressure differential. Opening. When the upstream pressure, inlet, is higher than the downstream pressure, outlet, the valve opens. The minimum pressure required to open the valve is called the cracking pressure. Closing. If the downstream pressure becomes higher or if the flow stops, the internal mechanism, disc, ball, or plate, seals against the seat, blocking any reverse flow. Swing check valve. A swing check valve, also known as a clapper valve, is a type of non-return valve that uses a swinging disc to allow flow in one direction while automatically blocking backflow. It is widely used in water, wastewater, and industrial systems because it is robust and cost-effective. How it works. The valve is entirely self-actuating, meaning it relies on fluid pressure rather than external power. Opening. When the upstream pressure is high enough to reach the cracking pressure, it pushes the disc, clapper, upward, allowing the fluid to pass. Closing. As flow slows down or reverses, gravity and back pressure pull the disc back onto the seat, creating a tight seal. Best used for large diameter pipes, low pressure drop, and horizontal lines. Parts of swing check valve. Body. This is the main pressure-containing housing of the valve. It connects to the pipeline via flanges and contains all the internal moving parts. Body seat ring. The stationary sealing surface located inside the valve body inlet. The disc closes against this ring to create a tight seal and prevent backflow. Disc, also known as the clapper. This is the movable element that blocks or allows flow. It swings upward to allow forward flow and drops down onto the seat ring to stop reverse flow. Hinge, the arm connecting the disc to the pivot point. It allows the disc to swing freely open and closed. Hinge pin, the rod or shaft around which the hinge and disc assembly rotates. It is usually secured within the valve body walls. Gasket, the sealing material placed between the valve body and the cover. It is compressed when the cover is tightened to prevent fluid from leaking out of the valve joint. Cover, often called the bonnet, this is the top plate that closes the valve body. It is bolted down to compress the gasket and provides access to the internals for maintenance when removed. Dual plate check valve. Best used for compact spaces. It is much lighter than traditional valves. Is a mechanism two spring-loaded semicircular plates that fold together. A dual-plate check valve, also known as a double disc or butterfly check valve, is a multi-purpose non-return valve that is much stronger, lighter, and smaller than a traditional swing check valve. It features two spring-loaded semicircular plates that hinge around a central pin. When flow starts, the plates fold together to open. When flow stops or reverses, the springs snap the plates shut against the seat. When are they used? Due to their compact design and efficiency, they are preferred in the following scenarios. Space-constrained areas. Because of their wafer design, they are significantly shorter and lighter than swing check valves, making them ideal for tight piping layouts. Preventing water hammer. The spring-assisted closure is very fast, meaning the valve closes before the flow can reverse, which prevents the damaging slam associated with other check valves. Large diameter pipelines. They are often the most cost-effective choice for large pipes, above 10-inch, because they require less material and are easier to support than heavy, bulky swing valves. Vertical installations. Unlike many swing check valves that struggle with gravity, the dual-plate spring-loaded mechanism allows it to work effectively in both horizontal and vertical lines. Low-pressure drop systems. The dual plates offer a more streamlined flow path once fully open, which helps maintain system efficiency. Parts of a dual-plate check valve. Valve body. This is the main outer casing of the valve. It is the thick metal ring that is installed between the pipe flanges and holds all the internal components in place. Plate. These are the two semicircular discs that act as the doors of the valve. They open to allow fluid to flow through and close against the seat to prevent backflow. Hinge pin. This is the central vertical rod on which the two plates are mounted. It serves as the pivot point, allowing the plates to swing open and closed. Spring. This coiled mechanism is wrapped around the hinge pin and pushes against the plates. Its function is to assist in closing the valve quickly as soon as the forward flow stops or reverses, helping to prevent water hammer. Lift check valve. A lift check valve is a type of non-return valve where the internal disc, or piston, moves vertically or in a straight line away from the seat to allow flow. Unlike a swing check valve that rotates on a hinge, the disc in a lift check lifts up using the pressure of the incoming fluid. How it works. The valve operates based on a pressure differential. Opening. When the pressure below the disc inlet exceeds the pressure above it and the cracking pressure of the spring, the disc is pushed upward, opening the path. Closing. When the flow stops or reverses, the weight of the disc, and often a spring, forces it back down onto the seat, creating a tight seal. Common types. As seen in your previous photos, there are two main variations. Piston check uses a cylindrical piston. These are excellent for high-pressure services and offer a very tight seal. Ball check uses a spherical ball instead of a disc. These are ideal for viscous fluids or slurries because the ball rotates, preventing uneven wear. When are they used? Lift check valves are preferred over swing check valves in specific industrial scenarios. High-pressure systems. Their design is inherently stronger and more compact, making them the standard for Class 600, 800, and 1500 applications. Steam service. They are the go-to for high-pressure steam and condensate lines because the guided movement of the piston prevents the chattering or vibration common in swing valves. Vertical upward flow. Because they rely on gravity and linear movement, they work exceptionally well in vertical pipelines where the flow is moving upward. Corrosive or hazardous fluids. As seen in your AMPO-POYAM photo, made of CK3MCUN, they are often used with exotic alloys for severe chemical service where a leak-proof seal is mandatory. Frequent flow fluctuations. If the flow starts and stops often, the lift check is more durable than a swing check, which can suffer hinge pin failure over time. Main components of a lift check valve. Body, the primary pressure-containing part that houses all internals. In lift check valves, the body is often T-shaped or L-shaped to guide the fluid in a way that pushes the internal disc upward. Piston/disc, the moving part that opens and closes the valve. It sits directly above the seat and moves in a perfectly straight vertical line. Seat, the stationary surface at the inlet port that the piston rests on to create a seal. Because lift check valves are used for high-pressure service, like your Class 600 and 800 examples, the seat is often made of a hard-facing material like stellite to prevent wear. Spring. Many lift check valves include a spring above the piston to ensure it returns to the seat quickly as soon as pressure drops. This helps prevent backflow in vertical lines. Guide. A part of the body or bonnet that ensures the piston moves strictly up and down without tilting. Proper alignment is critical to prevent the valve from sticking. Bonnet cover the top part of the valve that is either bolted or screwed onto the body. It allows you to access the piston and spring for maintenance without removing the entire valve from the pipeline. Gasket. A sealing component placed between the body and the bonnet to prevent the process fluid from leaking out under high pressure. A nozzle check valve, also commonly referred to as an axial flow check valve or a silent/non-slam check valve, is a high-performance non-return valve designed with an aerodynamic internal profile to minimize pressure loss and prevent water hammer. 1. As seen in your Orion photo, these valves feature a central nozzle or bullet shape, the diffuser, that allows fluid to flow smoothly around it in a streamlined axial path. How it works. The valve uses a spring-assisted disc that moves along a central shaft. 2. Opening. The incoming fluid pressure pushes the disc against the spring to open the flow path around the central diffuser. 3. Closing. Because the disc is spring-loaded and has a very short travel distance, it starts closing as the flow velocity decreases. It usually reaches the seat before the flow has a chance to fully reverse. 4. When are they used? Nozzle check valves are selected for critical services where protection of expensive equipment is the priority. 5. Pump and compressor protection. They are the gold standard for protecting multi-stage pumps and compressors because their rapid closure prevents backflow from slamming into the equipment. Critical non-slam applications. Used in systems where water hammer, pressure surges, must be eliminated. 6. The spring ensures the valve closes silently before the reverse flow velocity can build up. 7. High-velocity systems. Their streamlined, Venturi-style internal design reduces turbulence and pressure drop, $8/delta P, making them highly energy efficient for high-flow pipelines. 9. Pulsating flows. Unlike swing check valves, which can suffer chatter and wear out their hinges in pulsating flows, the guided axial movement of a nozzle check is much more stable. Variable flow conditions. They are designed to stay stable even at low flow rates, whereas other valves might flutter and damage their seats. Main components of a nozzle check valve. Body. The outer pressure-containing shell, typically designed with a Venturi-style internal profile to reduce turbulence and recover pressure. Diffuser, the nozzle or bullet A fixed, cone-shaped central component that streamlines the fluid as it passes through the valve. This part is what gives the valve its aerodynamic efficiency. Disc. The only moving part which travels in a straight line along the central axis. Because the disc is lightweight and has a very short travel distance, it can close almost instantaneously. Spring. A high-response internal spring that is wrapped around the shaft. It provides the force needed to close the disc before the flow reverses, eliminating the slam and preventing water hammer. Shaft/stem. The central rod that guides the disc, ensuring it stays perfectly aligned with the seat to prevent sticking or uneven wear. Seat. The precision machined sealing surface where the disc lands. In high-pressure models like your Class 600 example, these are often metal-to-metal seals for maximum durability. Bushing. Internal bearings that support the shaft, allowing for smooth, friction-free movement of the disc during thousands of cycles.